All right, so today we are going to simplify rational exponents. So what is a rational exponent? First we got to do a little bit of vocab. So rational exponents is an exponent in the form of a fraction is called a rational exponent. So everybody write that down in your notes. An exponent in the form of a fraction is a rational exponent. So I'm going to give you some examples of that just before we start. Okay, so if I give you something like 3 to the 1/3. So and write that down on the side. So you're used to doing like 3 to the 3rd. But now we're going to do 3 to the 1/3. So 1/3 representing your exponent. So now we're dealing with fractions. So in order to deal with the fractions, you have to understand what each part represents. So the first thing is that the n represents, it's called the index. So write that down, it's called the index. But really, guys, what it is it's the nth root. That's another word for it, is the nth root. What do I mean by that? You need one of those? Okay. So what do I mean by that? What I'm saying is if I say to you, the square root, so if I say the square root of 36, what's the answer? 6. So the square root of 36 is 6. So that is the square root. So what if I said to you the third root of 8? Does anybody know what that is? That means what times what times what, it has to be the same number, is 8. What's the answer? 2. So the third root of 8 is 2. Everybody understand that? So when we say the nth root, we're talking about this little number right here, which is your square root, your third root, your fourth, fifth, or sixth root. Are you guys with me now? So that's what the word nth root means, all right? So when I look at that bottom number, that fraction right here, this little n, that represents my root. So if I said to you in this form, if I said 4, write it down, 1/2, I would be saying take the square root. Are you guys sort of following me on that? Okay, does that make sense? Okay, the A represents the radicand. I-C-A-N-D. Okay, it is the radicand. Now, just for the record, we won't really use the word radicand very much, but it is terminology or some vocab that you should have in your repertoire. So there it is, okay? I know, right? It's okay. In order to simplify rational exponents, you actually have to convert it to radical form. So I'm going to show you radical form, and then some of you guys are actually going to be able to convert it without actually putting it in radical form. So here's what I mean by that. So if I have 64 to the 1/3, this actually means take the third, write this down, the third root of 64. That's what this means. So it means the third root of 64. That's all it means. How do we plug that into our calculator? Go ahead. Yep, you do. So if you look at the bottom of your notes, can you guys look at the bottom of the page of the notes? It says, how do we plug this into the calculator? I want you to write this down so you remember how to do it. So you have to put the root in there. Everybody write the word root. In this case, it's the third root. Okay, so we're doing the third root. So you would put 3 into your calculator. Then you would put second function. Can you write this down in your notes? Second function. And then you're actually using the X root key, which is actually the caret key. So if you see, it's the caret key, but it's a second function. I see it. So since it's a second function, it's actually the root key. And then you put in your radicand, which in this case was 64. Now I want you to write the word radicand, though, right here. And then press equals. Okay, so now going through the problem, if you put 3, second function, and then it's the caret key, which is actually the root key, right? And then the radicand, press equals, what do you guys get?
4.
4. Because the third root of 64 is 4. So this equals 4. In other words, 4 times 4 is 16 times 4 is 64. 3 4s make up 64. Does that make sense, guys? Okay. So if we look at this second example right here, which is 343 to the 1/3, okay, what is our root? What's our root? 3. So 3 raised to, or 3, the root of 3 to 343. So the 343 to the third root. Can you figure it out on your calculator? 7. Yep. So you put in 3, second function, the root key, and then your radicand, which is 343. So what does that mean? 7 times 7 is 49, times 7 is 343. Now we don't have to just use 3, we don't have to use 2, we can use any root we want. So for example, over here on the side, if I write in here, I want 32, and I want 1, and I want over 5. So 1 over 5. So I want the fifth root of 32. The fifth root of 32. So everybody put in 5, second function, your root key, and then radicand. What is it? 2. So 2 to the 5th power is 32. Are you guys following me on how to do that? Yeah. All right, so that's the first step. Now, we're going to practice a couple of these right here. So I want you to write it out. It's 3 third root of 8 equals what, guys? 2. The second root of 25 equals 5. And the third root of 2,197 equals what? 13. Now, here's what I want you to notice. We don't often see that little 2 out there when we're doing the square root, because it's kind of assumed that if there is nothing there, then it's a square root. So you won't see the 2. If there's nothing there, you know it's a square root, okay? But every other root you have to write in. Are you guys following me on that? Okay, so if you have that on the bottom of your paper, you guys can go ahead and flip that over to the other side.
Is this all working?
So now, if we look at the next set, it says, what does it mean if the numerator of the fractional exponent is not 1? What do I mean by that? What if I look right here, and I see that I have 5 as my numerator? Well, the numerator of the exponent actually represents how many times you multiply the base, or it represents the actual exponent. So what am I saying to you? Everybody circle the 5 and circle the 3. That represents your exponent. In other words, to the 5th power and to the 3rd power. Okay? I'm going to show you. Okay? So now we're going to use the same rule that we did on the other page, which we're going to take the second root of 4. So everybody write that down. The second root of 4, but after we get done, we're going to raise it to the 5th power. Okay? So ready? What is the second root of 4? 2. 2 to the 5th power is 32. So this answer is 32. Okay? Second example. So this is the second root of 25, all raised to the 3rd power. So ready? What's the second root of 25? 5 raised to the 3rd power. 125. You got it. Now check it out. Again, I'm putting the 2 here right now, but normally we wouldn't put that 2 there. I'm just showing it to you, right? Okay, let's keep going and practice. So if we look at this one, this is the 3rd root of 8. So 3rd root of 8 raised to the 5th power. So 3rd root of 8 is 2, right guys? To the 5th power. To the 5th power is 32. And you'll see these numbers over and over again. You'll see 32, you'll see 25, you'll see 125, you'll see a lot of the same numbers. Okay, this one is the square root of 4 raised to the 3rd power. What's the square root of 4? 2 raised to the 3rd power is 8. All right, do that last one real quick. And now as you do it, I want you to look up here and see if you can do it without even writing it down in radical form. So look up here real quick. Can you do it now that you know the pattern? Can't you guys say what's the 5th root of 32? What is it? 2 raised to the 2nd power. 4. So you can start to do it in your head if you understand it. So what did we do? We took the 5th root of 32 and we raised it to the 2nd power. 5th root of 32 is 2, to the 2nd power is 4. Okay? There's one more step. So the last step is, what does it mean if the numerator of the fractional exponent is negative? Well, we went over this yesterday. So, well, what is the operation, what operation does a negative exponent indicate? Yeah, what is it? Not opposite, but what does it tell you to do when it's a negative? Yeah, we're going to move it. It really means take the reciprocal. But in the case of a negative exponent, it means move it to the bottom. So write that down, move it to the bottom. Okay? And now if you take a look, we're going to do the exact same thing we just did, but when we get done, we're going to move our answer to the bottom. Okay, so ready? We're going to take the what? Root of 4. Square root of 4. So the square root of 4 raised to the, look, negative 5th power. Everybody write that down. So what's the square root of negative 4, or square root of 4? 2. Write this down, 2 to the negative 5th. Well, put it on the bottom, so it's 1 over 2 to the 5th, and then I actually want you to simplify it. What is 2 to the 5th? 32. So it's 1 over 32. All right, let's look at that second example. What does that 5 represent?
That's our exponent.
That's not our exponent. What is it? No, what is it? Our what? Root. It's our root. So it's the 5th root of 32 raised to what power? What exponent, I mean? Negative 2. So ready? What is the 5th root of 32? 2 raised to the negative 2, which is 1 over 2 to the second. Good job, which is 1 over 4. Are you guys following me?
Yeah.
Okay. So can you do the rest of these right here? Can you try these as practice problems? All right, I'd like you to practice them. I'm going to come around and check.